Good afternoon, students. Welcome back to Mr. Chen's master class. So sorry about for the previous video, so the cutout. And this one is a continuation of 5.4. So again, secant, cosecant, tangent, and cotangent graph. So this one, number 3, graph one side cos of y equals tangent of x, y equals cotangent of x by using the unit circle. So again, so what we notice that tangent of negative pi over 2, it's undefined. So that's undefined, so that means it's a VA. And then tangent of 0, it's always considered 0. So tangent of pi over 2, so then that it's another position where you'll find out it's undefined. And then tangent of negative pi over 4, then that would be considered negative 1. And then tangent of pi over 4, then that would be positive 1. So basically just connect those dots, so it's kind of like a bounded cubic curve. Okay, so it's a strictly increasing bounded cubic curve. Okay, so now let's see, what about for cotangent? So cotangent, what we have here, so cotangent of 0, it's undefined. And then cotangent of pi over 2, then that's 0. Cotangent of pi over 4, that's 1. And then cotangent of 3 pi over 4, and then that'll be considered negative 1. And then cotangent of pi, and which is considered undefined. So that one is, it's just like a reflected cubic curve. Again, it's being bounded. Okay, like that. There's no need to state the domain, the range, so that one is fine. And now graph two cycles of each of the following. State the period, domain, range, and amplitude. Well, basically that for the tangent and cotangent, there's no amplitude. There's no need to worry about that one. And then what we need to do here, so just find out the period. The way to find out the period, excuse me. So it's pi over 1/2. So then that'd be 2 pi. So for 2 pi, this one, so another thing that you might be considered doing is the one cycle test. You can always do the one cycle test to find out anything that's the starting position, the ending position. So this one you want to grab 2 cycle. Okay, so let's find out the one cycle test first. So for tangent, it's always being bounded from negative pi over 2 to pi over 2. And what we got here, the quantity is x over 2. So basically multiply both sides by 2. So negative pi, it's less than x, it's less than pi. Again, this one from negative pi all the way to pi, the VA. So that just consider one cycle. And then another cycle, then that'll be all the way to well, this one right here. So negative 2 pi, so that's another half of a cycle. Okay, so another half of a cycle, which is what, 2 pi. So negative 1, so down 1. So let's just grab one cycle first. So negative, so that means it's being reflected over the x-axis. So instead of going this way, so that means it's going to be reflected over the x-axis. So it's going to be like a reflected cubic curve. And everything should be shifted 1 unit down. So 1 unit down. 1 unit down here. And then over here, 1 unit down. So it's going to be like this for the first cycle. And then the other one, it should be the continuation. Okay, so negative pi, 2 pi, so that would be 0. So pi plus pi, then that would be 2 pi. So again, halfway through. So this one should be quite similar. Okay, so all the way down. And then this one too. Okay, so from 2 pi. So that would be the other half. Okay, going this way. Like that. This one should be strictly decreasing, so let me just fix that. Okay, so due to the reflection. Okay, so it's going through. And now, what about the domain, the range? So the domain, that's when you want to say that it's from negative 2 pi to 2 pi. But, well, let's see, let's start it with the interval. So negative 2 pi all the way to negative pi, close parentheses, union, and then negative pi all the way to pi, and then union, pi to 2 pi, and 2 pi here, bracket. And then for the range, so the range pretty much covers all the real number. So negative infinity to infinity. Okay, so for cotangent, it's quite similar. So this one you can always rewrite it with y equals 2 cotangent of pi, and then x plus 1. You can say that case 0 plus 0. Try to do the one cycle test for pi, for cotangent, excuse me. So 0 to is 0 all the way to pi, and then quantity, pi x plus pi. Subtract pi, so we got negative pi is less than pi x, is less than 0, and then divided by pi, so negative 1 is less than x is less than 0. Okay, divided by pi on each side. So negative 1 to 0, that's considered one cycle. 0 to 1, that's another cycle. So VA, here's the VA. Okay, so 2, that means the vertical stretch factor. So half of the distance right between. So this one would be considered 0 here. So negative 1/2. Here's 1/2. So without the 2, so this one it's just like up 1 right up here. But now due to the vertical stretch, so this one's going to be up 2 vertical stretch, and then over here, then that'll be 2 unit down. Okay, so negative 1/2, negative 1/4, negative 3/4. Okay, so simply connect them. Cotangent. And then get a cycle, exact same kind of pattern, exact same kind of trend. So up 2 right up here. Zero, and then all the way down to negative 2. Connect them. Alright, and then the domain would be considered negative 1 to 0, union, and then 0 to 1. Open and close parentheses. And then for the range, again, all real numbers. Negative infinity to infinity. Okay, so now what about number 5? Graphically, determine the intersections of graph y equals 2 secant of 2x, y equals 2 cosecant of x. Okay, so find out the period for this one. So secant of 2x, period, then that'll be 2 pi over 2, which is pi. Okay, so pi. And then the other one here, so that would be just like a parent graph of cosecant. So let's start it with the graph of 2 secant of 2x. So pi, that would be considered one full cycle. And we do know that secant. So secant, that means we started off at 0. So this one is up 2. So let's just divide that pi with 4 interval. 1, 2, 3, that's not good enough. So half of the distance between pi, then that'll be pi over 2. Okay, which is right here. Okay. And then half of distance between 0 and pi over 2, then that'll be pi over 4. Okay, so start with the first VA. And then 3 pi over 4, then that'll be another VA. Okay, so it's 2, so that means going this way. And then here's another one, down -2. Secant graph. And then the other part right here, at pi. Okay, going back. Symmetrical, so even function. So now what about for y equals 2 cosecant of x? Okay, so let's use different color for that one. So that one, the initial amplitude is also 2 cosecant. So that's based on the graph of sine. So for cosecant at 0, then that'd be the VA. The full cycle, then that'd be 2 pi. So we're going to continue with that graph here, but I just want to sketch the graph of cosecant next, and then we'll finish the graph of secant. And then what we got here, half of the distance, so this one pi, and now the VA. Okay, so, and then 2 right here, so started at pi over 2, so then that'd be 2. And then the next 2 position here, then this one will be considered let's see, with the stretch factor, so that's 2 units. So gotta be careful, so it's a vertical stretch. So 2 units up. 2 units. Okay, so it's gonna be going through this way. Okay. Supposed to be a U shape, okay. And now over here, similar. So at 3 pi over 2. So this one is also down here, -2. 2 unit with this vertical stretch factor. So all the way down to -4. All the way down to -4. Okay, so let's finish making a graph of secant. So secant, the other continuation, so this one pi, so here's and other one, so which is pi. Okay, so let's just go back to orange. Okay, so right here, so what we got, it's the first VA, it's pi over 2. And then 3 pi over 4, excuse me, 3 pi over 4. And then the other one should be right here, 5 pi over 4. Another VA. Okay, making sure that this one is the one we want. Let's see, hang on a second. 3 pi over 4, pi over 4, 3 pi over 4. No, the next one is supposed to be, okay, 5 pi over 4, that's right. So it's a little bit over. Okay, because this one is kind of close to each other. Okay, so pi, 4 pi over 3. Okay, so 5 pi over 4 should be a little bit over. It's too close right here. So you got to be very careful to find out the graph because this one is like overlapping. Okay, so 3 pi over 4, 5 pi over 4. Okay, so it's going this way. And then the next one should be 7 pi over 4. Okay, so 7 pi over 4. And then also showing that in other positions. So pi over 2, pi, and then the next one should be at 3 pi over 2. Okay, so then that'll be going up, going down this way. because that is like symmetrical. So half of it, the other half. Okay, up, down. So it looks like this one, and you'll find out the point where they intersect. Okay, and then right here. So the rest of that, it's the other half. Okay. So now let's try to evaluate it algebraically. It's hard to tell, from the graph. So it looks like we got one point where they intersect. Here's another one, so kind of symmetrical. And then also the one right here, so we're going to investigate by using the algebraic form. So 2 secant of 2x, so that equals 2 cosecant of x. So in other words, that secant of 2x is the same as cosecant of x. So one thing that we notice, so secant of 2x, excuse me, so in order to rewrite it, so this one is like a double angle. So the double angle is 1 over cosine of 2x. And then the other one here, it's considered 1 over sine of x. Okay? So for the double angle form, so cosine of 2x could be written as 1 over 1 minus 2 sine square of x. This one is 1 over sine of x. And then cross multiply, and you'll end up with 1 minus 2 sine square of x. So that equals sine of x. Bring everything together. So 2 sine square of x minus sine of x. Okay, take this one all the way to the right hand side. So 2 sine square of x plus sine of x, and then minus 1, so that equals 0. And then you try to factor it, so we do have 2 sine x. And this one is positive, so that means this one should be negative 1, and then the other one is sine of x plus 1. So what we found here, so 2 sine x minus 1 equals 0. So in other words, so that means sine of x equals 1/2. So if sine of x equals 1/2, so the first point where they intersect would be considered pi over 3. Pi over 6, excuse me, 30 degree. And also 5 pi over 6. Okay, so check that right here. So at this position would be pi over 6. Okay, and then right here, 5 pi over 6 for the x value. It's hard to see that from the graph because there's so many scale. And then right here, sine of x plus 1, set that equals 0. Where sine of x equals negative 1. So that, when does that happen? 3 pi over 2, the one that we found. So the way that we did it graphically, so basically that's exactly what we found for those 3 points. Okay. Okay, so now let's see what else. So find the equation for each sinusoidal curve. So one should be a sine wave, and the other one must be a cosine wave. Okay. So starting with this one. So let's say that if that's a sine wave. So let's find out that the amplitude. So this one is being bounded from 0 to 4. So that means the amplitude would be half of the distance between. So that means A would be 2. So let's say that we started at 0. And then this one, it goes all the way to about 1 cycle. It's an end curve like that, right? To 2 pi. So the period, 2 pi. So it looks like this one, it doesn't have any kind of phase shift, horizontal phase shift, but it does have a vertical translation. So normally it's like being bounded from -2 to 2, but this one is all shifted above the x-axis. So this one will be considered from 0 to 4. So that means the value of k would be 2. So for the sine curve, then that'd be easy. So then that'd be 2 sine of, in order to find the value of b, so period. So 2 pi divided by the period. Because normally the way to find the period, it's considered 2 pi over b. But now, in order to get b, it's 2 pi over the period. So 2 pi over 2 pi, then that'd be 1. So b is 1, so this one is just considered theta, or b theta, or 1 theta. And then what else? And then you want to add 2. Check that. So for the sine curve. Now, what about for the cosine curve? So for the cosine curve, so somehow, you know that the amplitude is still considered 2. Still considered 2. But for the cosine, so normally we started off at the max. But this one somehow is being shifted. Is being shifted by pi over 2 unit to the right. Okay, so pi over 2 unit to the right. Again, the period is still considered 2 pi. So from 0.5 pi to 2.5 pi is still considered 2 pi. So this one, so cosine, again, so b is still 1. So theta minus pi over 2, because that's being shifted, pi over 2 unit to the right. And also, what else you need to do? And this one, let's see, add 2. Okay, with the vertical translation. And this one, it's even easier. So this one, it's just like y equals, well, started off with cosine. So this time, the period has been changed. Okay, let's use different color. So the period from 0 to 4 pi. So the period would be 4 pi. The way to find the value of b, so it's 2 pi over 4 pi. So it's 1/2. So basically for the cosine curve here, amplitude, this one is just like 1/2. So 1/2 cosine of, okay, so this one's just equal to, so it's 1/2 theta. Okay, so check the words. So 2 pi divided by 1/2. So we got 4 pi for the period. And then 1/2 the amplitude. There's no horizontal phase shift. And there's no vertical translation. And then for the sine curve, quite similar. So sine curve, so this one just being shifted. And it's being shifted pi unit. While this one here, you can say that's a reflected pi unit to the right. Okay, so pi unit to the right. But it's reflected over the x-axis. Supposed to be like a roller coaster. So it's reflected over the x-axis. So it's negative 1/2. So sine of 1/2 times theta. And then minus pi. Okay, for that one. Okay, so any questions, any concern that you have, make sure that you fast forward or rewind the video, the part of the lesson that you feel kind of struggle or you need more analysis and explanation. Okay, so next time we'll talk about that 4.7. So this one, it's actually from chapter 7.4, the inverses, but somehow this one is kind of mixed it with the other trick stuff right here. Okay, so we'll talk about the inverses next time. Okay, so stay tuned. So I'll see you guys next time. Have a great one. Take care.